Hey everyone, this is Mr. Fugay, and as you probably can see now, I am not in class today. So I wanted to take a couple minutes to talk about your plan to work on today. In addition, I wanted to go over example 2 and actually show you 2 ways of that you can do that problem. So we'll do that in just a second, but just an overview. Once we do that, you're going to get a chance to try 4 different problems on classifying triangles based on that example. For numbers 1 and 2, I want you to do those by hand using either your calculator, writing out your formulas. But then for the other 2 examples, I want you to use the Desmos.com geometry tool. And we'll obviously demo that in just a moment. In addition, the remaining time of class today, I want you to watch this video on the midpoint formula. This is another important formula we'll be using on the coordinate plane. And then that will actually help you answer the remaining questions on the Desmos distance and midpoint slide. So slides 2 through 15 were on distance, 16 through 31 are on the midpoint formula. And when I'm back tomorrow on Friday, we will do an open note mastery check on the distance and midpoint formula. So please bring any and all questions to class tomorrow. I'll help answer them at the beginning of the period before we take that mastery check. But for this video, I want to actually talk about example 2 from your notes. So this is what it looks like here, and I have the points there defined. Let's do this by hand first, and then we will talk next about how we can do this using our calculator. So right off the bat, personally, what I like to do is to plot these points. Based on the way the coordinates are, I'm actually going to count by 2's. So this will actually be -2, -4, so on. So -2 up 4 would actually put me about here. For E, we'll go 2, 4, 6, 8, and then up 2, 4. So there's my point E. And then F is going to be 2, 4, 6, and then down 2 here. Now, the reason I really do want to encourage to plot these points is because this gives you an opportunity to take kind of a guess of what you think this triangle is. So as I look at this, my guess is that this triangle is going to be an isosceles triangle because my theory is that DF and DE are the same. Now, that's my guess. We're going to go and do the math here in a split second and figure that out. I also think this is an acute triangle. I could be wrong. There might be a right angle in this, but I don't think there's definitely an obtuse angle. So I want you to use your visual confirmation of this as a means of being able to help you really confirm if you're doing the work right or not. So let's go ahead and let's set these up. So we're going to set up our distance formulas first. So it looks like actually DE, if I drew it right, yeah, they're both at 4. So we can actually just count this length. So 1, 2, 3, 4, 5. So the length of DE is just going to be 5. For EF, let's go ahead and use those points. So we have 8, 4, and 6, -2. So when we set up our distance formula, it would be 6 minus 8 quantity squared plus, and then that's going to be -2 minus 4 squared, and we'll compute that in a second. And then lastly, DF, again, I'm using the points from up here. So DF would be 6 minus -2, so that's really 6 plus 2. And then lastly, -2 minus 4. So we'll go ahead and evaluate both of those, and then we'll take a look at those answers. Put those in my calculator. For the first one, I got 2 root 10. And then for the second one, I got 10. Now, remember, I originally in the beginning of the problem said that I think this was isosceles. And right now, it looks like that I'm wrong with that. But this is exactly why I like to visually confirm these things, because I forgot literally that quickly that we were counting by 2's when we were doing this. Remember, each block was counting as 2 from our initial problem. So this isn't 5. This is indeed 10. So that visual confirmation that I was looking for indeed shows me that this is going to be an isosceles triangle. Now, for the second part of this, we're going to use our Pythagorean theorem converse to confirm what I think to believe is that this is going to be a acute triangle. So 2 root 10 is approximately 6.3. So I'm going to go ahead and use one of the 10s. So this would be 10 squared, and you kind of probably know now where this is going, but just want to go ahead and confirm this anyways. So we would get this. So if I plug all of that into my calculator, we're going to get 10 squared plus 2 root 10. If you're going to put it in your calculator, make sure you put that 2 root 10 in parentheses. So when I do that, I get this to be 140. That's definitely greater than 100. This is going to once again confirm to me that this is going to be an acute isosceles triangle. Now we're going to take these very same points and we're going to do this exact same problem, but now I want to use the Desmos geometry tool to help me do the exact same thing. Go ahead and open up our web browser, and I'll go to The link's actually in the lesson plan, but I'll go ahead and just type it in. It was desmos.com/geometry. And when that opens, one thing that you can do here when you open up a blank one is go over here to the settings, and you actually want to turn the grid and the axes on so it creates that coordinate plane that we're working with. If it also helps, if you click on this larger A, it'll make it bolder, just a little bit easier to read. For this video, I think it'll be easier to go that way. Let's go ahead and define our point. So I'm going to say D is equal to, and you have to use lowercase, so make sure you do that, -2, 4, and then I have E equals 8, 4, and then lastly, oh yeah, there's something about E. We'll talk about that in just a second. There's a reason why we can't actually use that point. So it was 6, -2. So E is actually a reserved variable, as you probably have learned, I think in Algebra 2, that E is the constant 2.72. So I cannot use lowercase e, so we'll just go ahead and call it G. I know that might confuse things, but now it plots the points. If it helps, we can call this D, we can call this F, and then actually for this label, why don't we call it E, and then in parentheses, I'll say point G, just so that we remember that I had to change it for this activity. Now, if you want to connect to make a triangle so that you can see it, by all means, we can do that. We can go up here and use some of these tools up on the top of the screen. This is actually the segment tool. If you click the drop down, you can see we can create all sorts of different segments or different lines and constructions. So I'm going to click on segment, hover over D, click on F, hover over F, connect it to E, and lastly connect E to D. So now we get that exact same, and you click the arrow tool to go back so you can drag it. This is the exact same diagram that we had back from what we just did on OneNote a minute ago when we drew this. So to find the distances on Desmos, it's really, really simple. All we have to do is type in distance, parentheses, and then if I want to find DE, now remember I called that point G, so I know that's confusing, D comma G, there's that 10 that confirmed that we got earlier on the OneNote is correct. We'll do our next distance, and then that's going to be GF, and that's going to be 6.32. That is what 2 root 10 is actually equal to. And then lastly, for the final distance, we can do DF. And we see we got the 10 there as well. Now, if we want to do the Pythagorean converse all on this screen as well, we can actually do that too. So what I can do is I can take my 2 shortest sides and just square them. So 10 squared plus, and then we can just say 6.32 squared. That's probably good enough. And we get 139, and then, which is pretty much the 140 that we had gotten before. Do your 10 squared, there's your 100. So here is some algebraic work that proves the exact same thing we did before. We can use our snipping tool if we want to snip all of this and move this back over into OneNote so that we have documentation of the work that we've done here. But that should be everything here for today. So in your classwork, I want you to try 2 by hand, and then 2 of these I want you to go through Desmos geometry tool and try this out as well. Best of luck with your work today. Feel free to email me with any questions, or more importantly, bring those questions with you to class tomorrow, and I'll be happy to address all of them. Have a good rest of your day, everyone.